So students, let's welcome to this topic and what we are going to discuss about work, energy and power. In our physical world, we use the word work in many different ways. As for an example, I work in a college. You, the students, should work harder to achieve great results. So these are the various types of meaning by which we can define the word work. But in physics, the word work has a definite meaning. Whenever you pushes a book on the table, there is a work done. Whenever you throw a ball upward direction, there is a work done. Whenever you walks, there is a work done. So every time when a force causes a motion, it means there is a work done. Let's define it more precisely, more accurately. So work is always done by a force. Whenever we say that you pushes a book on the table, that means the force exerted by you has done the work on the book. Work done by a force can be defined as the product of the force and the displacement of the object caused by the force in the direction of the applied force. So in mathematical terms, we can write as W or work done. Work done, W, is equals to the applied force and the displacement caused by the force on an object in the direction of the force. Now here, as you can see, that two terms, that is force and displacement, both of them are vector in nature. You know what is a vector quantity? A vector quantity means that if a physical quantity has both direction as well as magnitude, it will be a vector quantity. And here, as force and displacement, both of them are vector quantities, but the work done or work is simply a scalar quantity. So it should be remembered that both of force and displacement are vector quantities, but their product, what makes the work or work done, is actually a scalar quantity. Now let's define the unit of work. As you can see that W equals to force into displacement, so in SI unit, the unit of work can be represented as the unit of force in SI unit is Newton, right? And the unit of displacement in SI unit is meter. So what will be the unit of work done in SI unit? Yes, rightly said you that it is nothing but Newton meter. Okay, now Newton meter is usually expressed by capital J, or that is Joule. In honor of the British physicist James Prescott Joule, Newton meter is usually expressed as Joule and it can be written as capital J. So the unit of work done in SI unit is, you can say it either Newton meter or simply Joule. Now in calculating work done of an object by a force, what is most important? The important term is force as well as the displacement, since these two are the terms which are responsible for the work done. Now if a force creates no displacement of the body, that is, if the displacement of the body after applying the force is zero, what will be the work done? The value of the work done will be zero, as because displacement is zero, so work done will be zero. For an example, if you are trying to push a wall for a day long, the work done will be zero, as because though you are applying a large amount of force, but since the displacement is zero, the amount of work done should also be zero. So the direction of the displacement of an object by the applied force is most important for calculating the work done by the force of an object. Because the displacement of an object may be in the direction of the applied force. This is the most simplified case. or the displacement of an object may be in the opposite direction of the applied force. The displacement of an object, it may be perpendicular to the applied force, or it may be with an angle, creating an angle with the applied force. So there may be a number of cases, and we have to calculate work done for each of these cases. So let's jump into the calculating of work done by a force on an object. Now let's calculate the work done where the displacement in the direction of the force, that is the object is displaced in the direction of the applied force. Here you can see in this figure, this is a block, a wooden block. Let us consider a wooden block at the point A, and after applying a force of magnitude capital F, the body or the block is displaced by an amount d in the direction of the applied force, and it moves to the position B. So what will be the work done? As from the formula we get that work done equals to force into displacement. So here W will be equals to capital F into small d, as d is the displacement of the object in the direction of the force. So this is the most simplest case to calculate work done. Now considering the case in which the displacement of the object is in the opposite direction of the applied force. Here in this case, this is a simplest example for this type of work done, that is here a ball or a body is thrown in upward direction. Now here in this case, whenever a ball is thrown upward, the force due to Earth's gravity pulls the ball in the downward direction. So here the ball is actually moving with a minus d amount of displacement. So the work done should be W equals to F into minus of d, or it will be minus of Fd. So in the third case, what I am going to show you, that is the displacement in the direction perpendicular to force. Let us consider this example. There is an aeroplane flying in the sky. Now this will be the direction of displacement, whereas the force of gravity due to Earth is in the perpendicular direction. So this force of gravity actually has zero work done on this aeroplane. So whenever the displacement of an object is perpendicular to the applied force, the work done should be zero. So here we are considering displacement of an object which is at an angle to the force. Let's considering this figure. Here an object is placed at a point A which is actually slipped down to the point B. Now here the weight of the block or the weight of the object is acting downwards, that is the mg, as because the mass of the object is m. So when the displacement of the object is AB, but in the vertical direction the displacement should be AC. And from the same formula of work done, that is force into displacement, here also we can calculate W, that equals to the force, that is mg. This will be the force, and the displacement of the object, that is AC. Now what is AC? From the figure we can say that AC is nothing but AB cos theta. So it can be written as mg into AB cos theta, right? So in general we can write it as mg as capital F, AB as the displacement d cos theta. So So the mathematical form of W equals to Fd cos theta. So students, so far we have discussed various ways of calculating work done. So what will be the general expression of work done? Actually, the general expression of work done is W equals to F into D cos theta. That is the last mathematical form which I have derived. Why this is the general expression of calculating work? Let's check this out. Case number 1. If theta equals to 0. Now what does it implicate? It implicates that the displacement of the body is actually in the direction of the applied force. So that means theta equals to 0, and then you will find that W equals to F into D, as because cos 0 equals to 1. So this is our first case in which I have shown you that if the displacement of the body is in the direction of the applied force, work done equals to F into the displacement. So this is the case. Now move on to case number 2. If theta equals to 180 degree. So what does it implicate? It implicates that the displacement of the body is actually in the opposite direction of the applied force, which I have discussed in case number 2, and here you will find that W equals to F into D into cos 180 degree, and as you know, cos 180 degree equals to minus of 1. So that means it will be minus F into D. Now let's move on to case number 3, that is when theta equals to 90 degree. That is the applied force and the displacement of the body is perpendicular to each other. What will happen? W should be equals to F into D into cos 90 degree, and as you rightly said that the value of cos 90 degree is actually 0. So the work done should be 0. Now let's move on to case number 4, and that is when you have applied a force and the displacement of the object is actually making an angle theta with the applied force, then W equals to F into D into cos theta. So this is the general expression of work done. Okay? Now students, let's move on to discuss energy.